technically I am on video. I started to watch the transfer of this last night. It is painful to watch yourself. Okay, so in the last class, we introduced you to the graphical presentation of vectors, and that consisted mostly that when you draw vectors, you have to make them the right length to correspond to whatever they're representing, and you have to point them in the right direction. And what we laid out for you is that when it comes to pointing them in the right direction, we use the concept of polar coordinates in math. So the length of the arrow, and just a kind of quick refresher, when you draw a vector, this end of it is referred to as the tail, and over at the other end, you have the tip. And so when you draw them, at least initially here, I just want you to draw them how they would be shown on a polar coordinate system. The tail always starts at the origin, okay? And the idea is that if I give you a particular vector that consists of a magnitude and then an angle, the first thing you have to be able to measure is what is the angle. And remember that what most people would call the positive x-axis, that is our 0 degree angle, and the positive y is our 90 degree, the negative x is 180 degrees, and the negative y is 270 degrees. So when you go to draw the list of vectors that you got from yesterday or the prior lecture, the first thing you have to do is, using your protractor, you have to figure out which direction do you need to draw the vector in. So what you would do, let's say the angle was that right there. Once you establish the appropriate angle for your vector, then using your ruler, you just have to draw a line that would be the appropriate length, which is represented by the V, and then you're going to put a tip on it. And remember, I mentioned that when you're doing things graphically, trying to put the tip or the arrow indicator right at the tip of the vector, sometimes if you make this really sloppily, it actually changes the length of the vector, and when you go to do vector addition, which we're going to do next, it actually makes your vector a different length than it's supposed to be, and if you do that often enough, it can end up messing up your problem. So I tend to put my arrow indicator back just a little bit from the actual tip so that I don't mess with the length of the vector. Now, once you have drawn this, what I would like you to do is to label out here by the end of it the vector, because you guys have vectors A through J. Now, you do not have to show me this, because you're going to do a lot of this, and that would just mess it up. This is the only thing that you're going to be showing me for each of the vectors that are on your vector list. So after you're done drawing the first one, you just draw the second one, and in the end, if you've done it properly, as some people, kind of thought about it yesterday correctly, it should look like a little starburst kind of pattern, because you'll have these arrows all emanating out from the origin of your axes. Now, what I'm going to do is I am going to give you a blank piece of graph paper, and I have protractors and rulers here. So for those of you watching this at home, you got to scare up a protractor and a ruler and some graph paper, although you could do this on lined paper if you played your cards the right way. And if you need any of those materials, you can email me and we can try and arrange something. But once you get your graph paper, I want you to go and locate more or less the middle of the paper, and I'll do this in blue, and I want you to draw a tiny set of axes representing your polar coordinates, and I do want you to label them 0 degrees, 90 degrees, 180 degrees, and 270 degrees on the ends there. And then I want you to draw the 10 vectors on your list on this. Simple enough? Okay. And where we're going with this is next week we will talk about how do you actually do math with graphical vectors, and this is where we get to move things around, and this is the part where people who understand you can do this mathematically sometimes get irritated because they're like, I can do this on my calculator and get exact answers. We'll get to that, but I want to give you a graphical experience with vectors first. So when we go do the math stuff, I hope you'll be going, oh yeah, this was like that stuff we did with the with the rulers and the protractors, but it's way slicker and more accurate once you can do math with it. But there's a decent amount of math things, steps that you have to go through to do that. And so one of the reasons that is so simple in today's world is we have much more powerful computational devices, calculators, that allow us to do that. But before that was available, people literally had to do this graphical thing, to get answers to vector problems. Okay? So I'm going to pass out the graph paper. You guys can grab a ruler and a protractor, and you go at it. All right? Go ahead and